Okay, written response number 2. That's a piecewise function. Well, you knew you were going to have to do something with a piecewise function. That should not come as a surprise to anybody. So we're going to draw a sketch. Okay. Now, again, this just has to be a sketch. It doesn't have to be anything terribly fancy here. First of all, I'm looking at the quadratic, okay, where x is less than 1. So y equals x squared. Okay, if I give myself a little bit, doesn't even have to be all that much, just a little bit of a scale here. It's going to go through those points, this one right here, so x squared is going to go up like this. And because the domain for this particular part of the function was restricted to x is less than 1, I'm going to come up to the 1, and it's going to be an open circle. I want to make sure that that's very clearly an open circle right there. Okay, because it's not going to equal, we're not going to get to x equals 1. Now, from this point on, we're going to go and be straight between 1 and 4. So maybe I'll give myself a little bit more of a scale there. The function's just going to be 4. It's going to be way up here. So starting here and including, it's just going to go along at 4. Constant function. Okay? Now, from this point on, okay, it's going to have a slope of -1 and a y-intercept of 8. So it's going to be a line starts up here and kind of comes down here. But let's just figure out here if it actually hits this point. So if you let x equal 4, okay, that's basically where this interval starts off. Now I know it's not including, so I'm going to put this open circle there, but just bear with me. Plug in the 4. -4 plus 8 is +4. And that is the same as that second function there. So it's going to be here, and then it's going to drop down with a slope of 1. Okay, and there we go. And so that's the piecewise function that we're looking at. Now, we're going to discuss the continuity. Well, this is discontinuous at x is equal to 1. I don't think there's any big surprise there. You can actually see the gap in the graph, but we typically want to explain what's going on here. And so what we'll say here is that the limit as x approaches 1 from the left of f of x does not equal the limit as x approaches 1 from the right of f of x. Okay? Because as we approach it from the left, we're getting 1, and as we approach it from the right, okay, we're getting 4, and 1 doesn't equal 4, so that's why it's discontinuous at x equals 1. It is, however, continuous at, I don't know why I wrote that at real huge, at x equals 4, because the limit as x approaches 4 from the left of f of x is equal to the limit as x approaches 4 from the right of f of x. And very importantly for continuity, that is equal to f at 4. Because without that being true as well, it's not continuous.